Picture this. You reach for your smartphone, and it's completely dead. You try booting up your computer. Nothing. Global AI networks drop offline. Autonomous vehicles literally stop right in their tracks, and the advanced defense systems of the world's leading superpowers just suddenly go dark. Sounds like a sci-fi movie, right? But that apocalyptic scenario is actually the fragile reality of our modern global supply chain. Why? Because an astonishing 90% of the world's most advanced microchips are controlled by just one, largely invisible company. If they stop working, the modern world stops with them.
Welcome to this explainer, everyone. Today, we're unraveling the ultimate hidden architecture of our global economy. The company we're talking about is TSMC, the Taiwan Semiconductor Manufacturing Company. We aren't just looking at a tech corporation today, folks. We are examining the fundamental layer of modern civilization itself, and really the high-stakes geopolitical anchor of the entire 21st century.
Section 1. The epicenter of global power.
Okay, let's dive into this. To really wrap our heads around TSMC, you have to realize that they operate at the sheer epicenter of global technological power. Without them, the incredible leaps we're seeing right now in AI infrastructure and all those highly complex autonomous systems that basically run our world would face an immediate collapse. And to put the stakes of this into perspective, try to imagine $10 trillion. Looking at this impartially through raw economic data, analysts calculate that any military invasion or critical disruption to TSMC's operations would instantly wipe out $10 trillion in global value. That's a catastrophic, civilization-altering number. It transforms a single company into literally the most guarded economic asset on the planet.
Section 2. Ecosystem of trust and density. So how exactly did they get here? How did one company build what analysts call a compound advantage that is virtually impossible for competitors to simply copy, even when those competitors are armed with billions of dollars in government subsidies? Well, it goes back to 1987. Founded by Morris Chang, TSMC basically invented what's called the pure-play foundry model, and this brilliantly illustrates the core of their entire strategy. It means they manufacture chips, but they don't design them. Compare that to integrated device manufacturers, or IDMs, like Samsung or Intel, who both design their own chips and manufacture them. Because TSMC only manufactures, they never compete with their own clients. If you're NVIDIA, Apple, or AMD, you can confidently hand over your most closely guarded designs to TSMC, knowing for absolute sure they won't steal your ideas to build a competing product. It builds an unprecedented level of trust.
But trust is really just one piece of the puzzle. Geography is the other big one. Take a look at the Hsinchu Science Park in Taiwan. This specific location creates a deeply intertwined physical ecosystem. You have raw materials, wafer manufacturing, testing, and packaging all sitting right next to each other, practically within a 1-hour radius. The incredible density of this supply chain creates a level of efficiency that is almost impossible to replicate anywhere else, simply because of the massive logistical and cultural hurdles involved. It's like a perfectly synchronized city operating on a microscopic scale.
Section 3. CoWoS, the AI bottleneck.
This incredibly dense ecosystem brings us right to a very specific engineering choke point. It's the ultimate bottleneck of the current AI boom, and it gives TSMC undeniable leverage over the entire tech industry. The crucial term you need to know here is CoWoS. That stands for chip-on-wafer-on-substrate. Now, this isn't just standard chip making. This is highly advanced 2.5D and 3D packaging technology. AI giants absolutely rely on this specific TSMC process to connect their ultra-powerful processors with high-bandwidth memory, or HBM. Simply put, without this advanced packaging moat, the hardware driving today's AI revolution just cannot function.
Now, what's really interesting about this slide is the human element powering all of that incredibly complex engineering. 4 to 5%. That is TSMC's extraordinarily low staff turnover rate. They've essentially built a dedicated army of PhD engineers with incredible discipline and a deeply ingrained work culture. And because these highly skilled people stay at the company for decades, TSMC accumulates what researchers call tacit knowledge. It's that deep, unwritten, almost instinctual know-how for every tiny little step of manufacturing. Honestly, it's a dynamic that Western corporate governance models are finding incredibly difficult to match.
Section 4. Taiwan's Silicon Shield. Let's move to and see how this builds into a powerful geopolitical weapon on the global stage. So, panning our lens out a bit, we arrive at the fascinating and highly strategic concept of the Silicon Shield. Because the entire globe is so deeply reliant on TSMC economically, this reliance effectively acts as a protective barrier for Taiwan.
Remember that $10 trillion figure we talked about earlier? A military invasion would trigger such catastrophic global economic fallout that the Silicon Shield practically holds World War III at bay. These factories are simply too vital to the survival of the world's leading powers to be destroyed.
To really understand the geopolitics at play, we need to look objectively at the global tech war. On one side, we have the CUDA software standard, heavily backed by the US and Taiwan ecosystem, specifically NVIDIA and TSMC hardware. This is basically the de facto standard globally. On the other side, we have CAN, which represents China's massive push to build its own software and hardware stack, all while under heavy international sanctions. While companies like SMIC and Beijing are definitely making efforts to advance, they fundamentally lack access to critical equipment like EUV lithography machines, and they just don't have that global ecosystem of trust we mentioned earlier. That significantly limits their pace in achieving true technological sovereignty.
Section 5. Diversification and Vulnerability.
Because of all these simmering geopolitical tensions, the world is nervously waking up to the fact that keeping all of its technological eggs in one geographic basket is incredibly dangerous. And this leads us right into the fragile reality of diversification. Global efforts to move this invisible giant away from its home base are causing some massive industrial friction. TSMC is actively trying to balance these geopolitical pressures by building new fabrication plants, or fabs, in places like Arizona, Japan, and Germany. But here's the kicker. Building and operating these foreign plants is proving to be twice as slow. You just can't copy and paste the magic of the Hsinchu Science Park across the globe overnight. And get this, not only is it twice as slow, but these international facilities are also a whopping 50% more expensive to run. The hard truth emerging from all these diversification efforts is that the label Made by Taiwan vastly outperforms the simple geography of Made in Taiwan. That unique culture, the hyper-dense supply chain, and all that decades-old tacit knowledge, it just doesn't export easily.
So the crucial point is that even with all these attempts at global diversification, the overall AI supply chain remains terrifyingly fragile. There are three critical failure points to keep in mind here. First, there's the absolute reliance on a single company, ASML, for the highly specialized equipment needed to make the chips. Second, there's a heavy dependence on DRAM memory suppliers like Micron, Samsung, and SK Hynix. And third, the ever-present, very real risk of supply chain sabotage. Any deliberate disruption to these vital links instantly creates a 21st century kill switch scenario.
Section 6. The uncopyable monopoly.
When we synthesize all of this academic and market data, a super clear picture emerges. TSMC is an uncopyable monopoly. Their unique blend of hyper-specialization, geographical density, and ironclad trust makes them the ultimate geopolitical arbiter of our time. As the world pushes forward into the absolute frontiers of AI, racing toward 2-nanometer chips, 1-nanometer chips, and eventually quantum computing, humanity remains entirely tethered to TSMC's capacity to keep innovating at an exponential pace. Meanwhile, other nations are largely just trying to survive the race, using regulatory protectionism and state subsidies like the CHIPS Act. Which leaves us with this final hanging reality. We've built the most advanced, interconnected civilization in human history, and it is all balancing on the tip of a highly localized, hyper-specialized silicate needle. Can the modern world actually survive if this 21st century kill switch is ever flipped? Really think about that the next time you ask an AI a question, or simply turn on your screen. Thank you so much for joining me for this explainer. Keep asking the big questions, and I'll see you next time.